Viewer, today's video. Today I want to have a class with my making class. Remember, I do have two classes, one on agriculture and the other one on LED signboard making. Now, I know many a times when farmers get such kind of content, they uh, many a time they may uh, ask themselves, where is the direction, where are we heading to? But we are fine. I do according to what you request. So I have some uh, technicians who have some questions, and they wanted me to deal with some concepts that I'm going to deal today about the power, the AC current, and how to connect that AC current to our LED signboard, and everything about it, how to calculate the resistor required, and how to even build the rectifier bridge using the diodes, the ordinary diodes that we normally have. So if you are new to this channel, please remember to subscribe to my channel below. You can give it a like, you can leave your comment over there. If you are a farmer, uh, just stick around. If you have a question on farming, you will let me know. Remember, or even my numbers are in my channel, so you can reach me, and if you want me to tackle certain information, then I will do that. For today, let me have the class with the LED making technicians. Now here we go. Now, like we are having this kind of LED. This is an M-Pesa LED, M-Pesa LED, as you can see it. I just want to write it and then see how it will work. Just want to light it, and then I will show you how. I have a model 1 for today. I have a model 1 for today, so just keep on tuned. Everything will be fine over here. So as you can see, that is an M-Pesa signboard, and has the green, the white, and the red, and all these LEDs that you can see. Hizi zote ambazo unaona zote hazijaunganishwa pamoja, kwa sababu kuna hizi za white lazima ziwake at a certain brightness. Even hizi za red lazima pia ziwake at a certain brightness, and then the green one have to light at a certain brightness. Now this kind of brightness is determined by the resistor value, also determined by that's how it normally work. Also determined by, you see, this is, we are using the AC current. The AC current here, this is the AC current. Then it gets in over here, and then itafika sasa mahali tumeweka bridge yetu. Now at the bridge, now hapo ndipo sasa inakuwa imegawanywa sasa to different kind of the LEDs, the white, the red, and the green, as you can see. But remember, we have the bridge, and we have three resistors. How do we calculate those resistors? Now that's where the question is, and how do we know which resistor to use now, and how do we really contract, or tunatengeneza aje hii the bridge, inaitwa Wheaton bridge, yenye inafanya rectification from AC to DC, AC to DC. Let me show you how to go about it. Let me show you how to go about it. Now for that, we must have an ordinary diode, and the ordinary diode's symbol is normally like this. That is ordinary diode symbol, ordinary diode symbol. This one is minus and this one is plus. So for us to have a rectifier, so we need to have two wires. This one are for AC in. Now this is something that we will have AC in. Now if we can have other wires for, let's say this is plus current, and then on the other side we have a negative current, because we want to rectify this AC from the kutoka kwa stima. AC inaingia 240 volts, tunataka sasa to rectify it using the diode ili iwe 240 V. This is volts for, these are DC. This is 240 volts for AC. We want now to transform. Now for us to attain a plus using a diode kutoka hii side, sasa lazima sasa hiyo utaishika na positive, upande wa positive, then inakuja to that point. From here, remember our current, the AC normally alternate. When on the other side it is positive, the other side is negative. When the other side is positive, the other side is negative. When the other side is negative, the other side is positive. That's why we normally call it AC, alternating current. So when it is alternating, when it is positive on this side, itapita hivi, itapita hivyo. So on this side itakuwa negative. Negative yetu tunataka ikuje pande hii, so negative yetu itachukua na negative, upande wa negative wa diode, upande wa negative wa diode inaenda hivyo. So that we may have a negative on the other side. Don't forget that we also have another turn. Tuko na mara ingine ambayo sasa upande huu kutakuwa ni positive. Wakati upande huu kuko positive, current haita move hivi, lakini ita move kulingana sasa na venye tunafaa kuitengeneza tupate positive hapa. So ita move on this side and give a positive sign of a diode, and then that is it. Hiyo sasa inatupea diode, sasa inatupea positive sasa on this side. So tumesema hapa ni positive, so positive haiwezi move hivi juu hapa ni negative, na positive pia ita move hivi. So ikimove hivi ndio hii iko hapa, haiwezi enda pande hii kwa sababu pande hii ni negative. So hii tumepata positive yetu. So when this side is positive, on the other side is negative, na negative haiwezi enda kupitia kwa hii, tunataka ifike hapa, so tutaipea negative ya pande ya diode, tutaipea negative, ndio hiyo negative. So that's how the bridge should look like. That's how the bridge should look like. So that bridge nimetengeneza na iko hapa, this one. That bridge tumetengeneza and it is over here. So here we have 4 diodes. These are the 4 diodes kulingana tu na venye nimeichora. So sijui kama zinaonekana mzuri, but you can see the negative. Hii ni negative, pande hii ni negative, hii ni negative kulingana na venye yetu iko hapa, negative na negative, positive na positive. So as you can see, negative, negative, positive na positive. So once we have rectified from AC to DC 240, and we will see, we will do the measurements and we will really see how it work. And I let me just check it right now. Give me a minute. With my gadgets over here, I think I will use this one for just want to measure the current we are using. So the current, so for me to measure the current, I'm over here. Just want to know the current. So it's at 2. Is it visible, really? It isn't. 265. Now let me just connect my device over here, and I must be very careful because this is current, and current don't joke with any kind of human being. So I know what I'm having over here. So I just want to do the measurements over here. So this is current, direct current, current, alternating current. On the other side, let us see what is. So what are we getting? Is it giving us the measurement? 240, 246.7 there. So that is the AC according to what we are having here. So the DC, let us see the DC, what we will get from the DC, direct current. Direct current is giving us almost the same figure. Now remember, it is DC. DC is very dangerous when handling this system. Don't touch any part of the circuit because of the hazard that it is contained there. Now, after we have done all this rectification, we then require to this positive, this negative, tunaifungilia kwa the negative part of our LEDs. And kwa system yangu ya leo niko na LEDs hapa. This is the back part of my LEDs zenye nitatumia kama sample. As you can see them, I have a number here. So hope you can see them, and it is very good that we can count them, tuhesabu tuone ni ngapi. 1 2 3 4 5 6 7 8 9 10 11. 11 multiplied by 2, that is 22, plus 1, that is 23 LEDs. 23 LEDs. So having these 23 LEDs, hii mahesabu ya LEDs itatusaidia kujua resistor value yenye tunafaa kuweka. Lazima tuweke resistor value kwa positive ya hii yenye tumefanya rectification. Without that resistor, then hizi LED zetu zote zitachomeka. So we must have that. So we have to do some calculation here. Kidogo tu some calculation over here. The calculation huwa tunafanya na, I remember there is this kind of formula yenye tulipata huko high school. This formula is very important, and what we should know for LEDs, current inafaa iwe 0.025. That is current amperes. That hii current yenye ina move kwa the LED. So this is a figure that you should know. Now, what about the volume, the value of the volts? Volts tunahesabu kwa hizi LEDs. LEDs ni 23. So 23 LEDs huwa tunahesabia 2 volts for every 1 LED. So this translates to 2 multiplied by 23 tunapata ni 46 volts. So 46 volts ndio tunataka kwa 240. So we only need 46 volt kwa 240. So what do we do for us to attain that 46 volts kwa 40? So what we really require is a resistor value that will, can we get the difference, we do the minusing, tufanye kutoa hizi, tutoe hii na hii tuone ni ngapi tunapata. So this is 240 minus 4 what 46, hiyo tunapata ni 194. Yeah, 194. We are getting 194 volts. So 194 volts hizi ndizo zinaweza ua our LED. So we need a resistor that will really consume all this, yenye itapunguza hizi kila kitu hapa, a resistor. So na ndio hii sasa tunatafuta. So resistor, from the formula here we will say that V is equal to IR. This is volts is equal to current multiplied by resistor. You can divide everywhere by current. So therefore tunapata resistor value should be the same as the value of this volts, then divide by our current value. Current is in hii, so tunaenda direct to our mahesabu. So tunapata ni 194 divided by current, which is 0.025 amperes. So this is V. So VA is normally ohms. It's normally ohms. So we divide. Dividing, what should we get really? What should we get really? So this one will be like 194,000 divided by 25. So somebody to do let me find a calculator for that matter. So I'm having my calculator here. So calculator is giving us what? Calculator that is what? 194,000 divided by 25. So we are getting, that's what we are getting, 77660. So to be on the safe side, a 10K resistor will be the value here. So 10K resistor, how do we calculate, how do we know the 10K resistor? How do we know the 10K resistor ni gani? From its color code. Color coding, so unaiangalia tu hivi, sio lazima uende kwa duka, unaweza pata kwa other component, so utajua. And let me teach you something to do with resistor color code. Resistor color code inakuwa na color, so inakuwa labeled like we can have, this is resistor, iko na color moja hapa, ingine hapa, ingine hapa, ingine hapa. They are normally 4. So we have 4. So hii inakuwaga ni moja, hii ni mbili, then ya tatu ndio inakuwa multiplier. Hii ya tatu sasa ni C, so call it A, B, C. D sasa inakuwa ni tolerance. Tolerance inakuwa ni tolerance. So let me just give an example. Like sasa hii yenye tuko nayo hapa, tutajua ni 10K 10K ohms. Hii ni kwa color ni gani? Lakini wacha tu niwaonyeshe how to have that color, how to develop those colors. Mtu anasema bad boys lift our young girl, but violet, give willingly, something of that nature. So lakini after tumemaliza hapa kuna gold and silver. Let me show you now. This is normally number 1, 2, 3, 4, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, like that. Then this is a tolerance of 5%. This is a tolerance of 10%. So black, bird is normally black, boys is brown, this R is normally red, O is orange, this is yellow, green, blue, violet, gray and white. So and then hapa mwisho kuna gold na silver. So hii ya mwisho inakuwaga either gold or silver, so that is now the tolerant. So tunataka hii which is 10 multiplied by 10 power 3. That is now our resistor. So 1 ni brown, then 0 ni black, 3 hapa which is C ni orange, like that. So hiyo resistor sasa ndio utatumia kuweka wapi? Kuweka kwa system yetu like I have today. So I think having done that with the formula V is equal to IR, na ujue ya kwamba the current inafaa kuwa ni 0.025 amperes yenye inafaa kutembea pale. Hii V utacalculate kulingana na namba ya zile zako zenye uko nazo. The maximum we normally go zinakuwaga ni kama 80 LEDs, kwa sababu 8 LEDs ukifanya mahesabu yako itakuwa ni 160 volts. Ukifanya minus utapata kitu pale after kunini, then hapo ndio unapata ya kwanza inakuwa ni 1K. You can use 1K for 80, lakini sasa hii utakuwa ume calculate hivi vote. Once umepata sasa the value, then you can come to the color code ujue ni gani. Hizi unafaa umaster zote. You have to do the mastery of that. Okay, now I'm almost through. Hiyo yote tumefanya. Having now done that, sasa tuko hapa. Tunataka sasa kuwasha hii. Kuwasha our system. Now, I want you to pay attention over here. I want you to pay attention over here. Kwa positive yangu, kuna hii cable yote imekuja hivi. Huu mwisho ndio tunaweka resistor. Ndio tunaweka resistor ile ambayo tumehesabu. Hiyo ndio iko hapa. Na hii resistor pia kuna vile ambavyo unaweza regulate the brightness of your LEDs. Unaweza taka ziwe so bright ama zisiwe that bright. So that is now upon you. Wewe ndiye utajua hii utachomelea wapi. So you can see already negative tushachoma from our bridge. Negative tumechoma. Hii sasa ndio positive. Positive lazima iwe na resistor. It must have a resistor kama hutaki hizi vitu zako ziungue. In fact, hiyo resistor unafaa kufunga hii side mzuri. Usipofunga kuna venye utachomelea hapa and then this side yenye hutafungilia iguze huku. Iguze kwa circuit. Kwa sababu circuit yetu wakati mwingine iko naked mahali kuingi. So naked. So therefore hii lazima ufunike. Usipofunika hapa na ujue ya kwamba unaweza weka ka resistor kadogo, ukiweka kaanze kuchomeka. So we normally advise that uweke tape. Na sana uweke ile tape ya white, not this one. Uweke ile ya white. Not even the globe tape, no, the sun up, not those one. Ile ya white. Hiyo uweke hiyo sasa. Ukishaweka ile inakaa karatasi, huwa haichomeki. Kwa sababu hii nikiweka then kama iko too small itachomeka and then the coating iondoke. Ikishaondoka inaweza guza anywhere. Ikiguza anywhere in the circuit, then hizo mataa zote zimechomeka. So let me show you how to write this system. As I told you, you must be very careful when dealing with all this. You must be very careful when dealing with all this. So I don't know how I will do it, because so let me put them that way so that you may be able to see very well. It is on. So mimi ni kuguzisha tu hapa. Hapa ni mwisho. So you can see how they are writing. So I can decide probably istaki hiyo brightness, nataka iwe somehow brighter. So for that I will nitamove huku. You can see. Naweza songa anywhere nikiwekea itafanya tu. And that's why until upate the brightness that you want. The brightness that you want. You just move this one na uhakikisha ya kwamba iko na resistor. So naguzisha the other part of the resistor. Hii ndio positive. Ikiguza kama haina resistor, then hii mataa yako yote inachomeka. So how do you determine the what? The brightness. So you find that huko mwisho ukiweka huko, hii mataa itakuwa so bright. So bright. Brightness inaenda ikipotea. Like that. So so I'm sure now you know how to go about it, how to make the Wheatstone bridge. You know how to make the Wheatstone bridge, how to connect to the power, and how to use it. You must lazima ufungulie resistor, na ni resistor yenye inafaa. Yangu hapa ni kubwa sana kwa sababu the LEDs ni kidogo sana. So hii resistor value must be very high ili iweze kusupply that power. Remember, kama uko na LED kidogo, then inamaanisha your resistor must be very high for it now kuondoa ile power yote mingi. So thank you very much for them that have watched, and if you are new to this channel, remember to like, you can leave your comment, just subscribe if you haven't subscribed yet, and just leave your comment for us to engage more. Thank you very much for watching. See you in the next video. Thank you.